Good afternoon, and welcome to this webinar on how customers can open up new possibilities with SAP on AWS. I'm John Stullard. I'm a Partner Solutions Architect for AWS, and I specialize in SAP workloads. I've been with AWS now for the last 2.5 years, and prior to that spent another 15 years or so working in the SAP world. In my role here, I work with our customers and partners across EMEA on all stages of their journey, whether it's initial migrations of their SAP workloads to AWS, helping them optimize and run better once there, or extending what they can do by utilizing the now more than 165 services we have in the AWS cloud. So I hope you caught my colleague Adam's webinar last week, where he focused more on the earlier phases of that journey, but if not, be sure to catch it on demand. Today I'm here to talk about, and more importantly show you, just some of what is possible with our wider services when you run SAP in the AWS cloud. So before talking about the extend part of the customer journey, it's important to look briefly at the history of our alliance with SAP, as the achievements along the way are key planks of this journey. So I'm sure a lot of the attendees here will be familiar with this slide, but it's worth emphasizing a few points here. So in 2008, SAP became a customer of ours, and we formalized our official partner status in 2011. From there, you can see from the curve of the graph that our certification and support expanded rapidly until you could run the vast majority of SAP's on-premises portfolio on AWS, which is going back more than a few years ago now. A key further release was in 2016 with the release of our X1 platform. So for the first time ever, you could now launch a completely software-defined virtual machine in the cloud that could scale up to 2 terabytes of RAM and 128 vCPU, or scale out to 14 terabytes. So of course, we've since built on the success of these instances to really extend what's possible in the cloud. With 4 terabyte instances a year later, 6 to 12 terabyte instances last year, and underlying those most recent instances, those high memory instances, was a significant leap forward with the introduction of our Nitro system. But I'm not showing this slide to focus just on the engineering, as impressive as I do think it is. You can see from our more recent announcements in the graph that for some time now our focus has moved beyond just infrastructure and into making it easier to extend what's possible for your SAP workloads on AWS. So at Sapphire this last month, I had the pleasure of announcing our S/4HANA Quick Start, which allows you to load your software to an S3 bucket and have AWS automatically install S4 for you in just 2 to 3 hours with an underlying HANA database, or even configured as a high availability HANA pair using HSR. So we've also worked with partners to introduce our solutions base, where we now already have 31 entries and counting, helping customers automate mundane aspects of their SAP environments and remove that undifferentiated heavy lifting, allowing them to focus on adding real value. We've also worked with the SCP team to support it in 7 regions worldwide now, significantly more than any other provider. And in that same vein, another great example of extending what's possible by integrating with our wider services was another announcement at Sapphire, where we released new integration features between SAP's cloud platform and our IoT services. I'll touch on that more in just a bit. Aside from all of this, of course, we've formed a strong partnership with SAP on their software as a service products, products such as SuccessFactors, Concur, Hybris, Fieldglass, and others, as you can see on the slide there. So that partnership and the engineering feats behind it have enabled our customers to have great success running SAP in AWS. As a result, we've now got thousands of enterprise customers running their mission-critical SAP workloads in AWS, and they're already seeing big business benefits. I'm not going to go through all the logos on the slide here, of course, but I'll call a couple out. I think it's worth emphasizing some of the real-world benefits that they've seen. A customer I've worked directly with is NG, for example, who migrated their new S/4HANA Common Finance project to AWS. And they did that to achieve an ability to rapidly scale during a short development timeframe. And this meant that they could ensure that their large functional teams had access to SAP landscapes as and when they needed them, and that those systems were performant for them as well. And this overall cut delivery time of their new business framework in half. So that's a huge difference. And what's interesting about it as well is that it's a difference that is not just seen at the infrastructure level, but is actually seen at the business level and is therefore going to make a much bigger impact than you would see at infrastructure alone. Another great example is Compass Group, who moved their ERP landscape to AWS to solve severe performance issues they were having. They were seeing that they had very high SAPs requirements for their systems, well into the many hundreds of thousands of SAPs. And they were also seeing difficulty scaling the environment for business growth and peak processing times. By moving their ERP system to AWS, they reduced database response times by almost 45%, and they also reduced their RTO from 5 days to 2 hours. All of that while being able to scale to meet peak processing workloads much more effectively. And then another great example is Sumitomo Chemicals, a major chemical manufacturer operating in a wide range of sectors. Their ERP instance runs a huge number of batch operations to the tune of around 200,000 SAPs. Now, by moving to AWS, they've already cut down their SAP job processing times by 40%, and the migration has also enabled them to implement disaster recovery solutions that were not possible in their on-premises environment. So as I said, we see this as a journey that we take with our customers. And in as much as there is a typical customer journey, the high-level pattern we see is shown here. First of all, get your workloads onto AWS, migrate. That's step one, of course. We often see step one and step two done at the same time, actually, because it doesn't necessarily make sense for a customer to go through a digital transformation to S4HANA or BW4HANA, for example, and do that in an on-premise world. So for more information on those phases, I again want to give a shout out to Adam's webinar, which is available on demand, because he goes into those two phases in a lot more detail. But once you've moved your data to the cloud, you can then allow the wider portfolio of cloud services to inspect and enrich that data. And lastly, manage and operate. So follow the principles of DevOps. So these are the parts of the journey that we'll focus on today. So, of course, in that journey, infrastructure migration is a mandatory first step, but it is often only the first step in our customers' business transformations. So, of course, the process efficiency, the agility, the reduced cost of ownership that I mentioned in some of our customer examples that result from these cloud migrations to AWS are attractive. But the more compelling reason for the move, in my opinion, and from what we've seen working with our customers, are the opportunities that AWS can provide them. And that's in the areas of applications and APIs, Internet of Things, big data analytics, and DevOps, as I mentioned already. And those are all supported by a solid foundation of machine learning. So these are about looking at AWS to help them extend their business processes beyond just infrastructure. So let's jump in and dive a bit deeper into these four pillars. And let's start with apps and APIs. So our customers are looking for a connected experience for their three primary stakeholders: their own customers, their partners, and their employees. Now, all these three stakeholders are consuming various business processes enabled by SAP and non-SAP systems through multiple channels. It's not just web applications or mobile apps anymore. Data is being consumed through other kinds of devices like voice-enabled applications, chatbots, IoT devices, augmented reality, and virtual reality apps. Conservative estimates predict that by late 2020, 30% of customer transactions over the web will be through devices that don't have a screen at all. It will be driven instead through voice-enabled apps. And it's only a matter of time that users expect the same level of interaction with enterprise data as well. And in fact, it's already happening. So we're increasingly seeing customers wanting to do more with conversational apps using Alexa at the workplace. So it's worth thinking about whether your SAP application is ready for those innovations. One of the key components of omnichannel experience for your users is the ability to integrate with SAP data without being tied into specific user interface technology. And APIs play a critical role in this. So of course, there's lots of potential use cases for integration. Mobile apps, a pretty common scenario these days, of course. So I'm actually personally working with one customer building out integration between their mobile apps and their back-end SAP systems to allow their customers better management of their energy. So a simple example of that is by allowing manual meter reads, for example. Alexa skills is actually an example that crosses multiple pillars here, and I'll illustrate that in a bit more detail later on. I'm not going to go through all of these. We do actually, I will be showing examples of others as well. I'll call out customer service powered by chatbots. So I also have a couple of chatbot examples to go through as well. Another great example of a customer using these services is Eon. So Eon used the API Gateway, EC2, Lambda, and DynamoDB to build an energy monitor that integrates with their backend ISU system. For those of you who aren't familiar with that, that's SAP's industry solution for utilities. They did a great presentation on this at our Berlin Summit earlier this year. There's a machine learning component to that. They train models for aiding in wind and solar forecasts, but that training is done only once per day with evaluation 4 times per day. So there's no need for an always-on instance. And instead, what they did was they followed our well-architected framework to go through iterations of optimization across all the pillars of our well-architected framework. So they use serverless where it makes sense, and small EC2 instances, and even initially Elastic Beanstalk, where they needed longer running jobs. So they gradually optimized and refactored from there, as I say. And one example of that was that because of the pure consumption model of or serverless services like Lambda and DynamoDB, even before they optimized, they started out at very minor running costs, about $750 per month. Early straightforward optimization reduced that very quickly to just $300 per month, and ultimately they were actually able to replace much of that functionality with direct S3 access, so static access, and reduce that already low $300 per month access to a tiny fraction of that. Okay, so I said that we're going to actually show, not just talk about this. So let's look at a quick demo of a mobile app example here. So here we first need to log in, of course, and we're going to log in and authenticate ourselves, and we can simplify this by using Cognito. So in this demo, it's been rapidly prototyped by a colleague of mine, and he used Cognito to do that backend authentication. You can then see a list of business partners, and this is read from the backend SAP system via API Gateway. So we can add a new account here, or we can look at existing details, as you can see here. So if we go into an existing business partner, we can go ahead and actually scan a business card. And what this will do is it'll automatically recognize the text on that card. So I'll jump ahead a little bit here. And you can see that it's read in all of that data. Now all you then need to do is map the fields you want, and you can go ahead and save that contact. So once you finish mapping the fields you want, go ahead and save the contact, and you'll see that contact appear in your list of contacts for that business partner. You can also use Lex. So I mentioned the chatbot interface. Here's one example of that. I'll be showing more later. And so you can actually chat with Lex. This is really easy to build in a Lex backend. And this just forms request response mechanisms. So you can see you can just ask for a specific account. Go ahead and search for that account. It'll bring up all accounts that match that name, as you can see here. And you can see that business partner and all of the contacts and now orders for that account. You can also go in and look at the products that those orders have been made on, and that's going to load our Sumerian augmented reality service, which shows you a drone here that is what's actually being ordered. And the idea here is just to do a very quick demonstration to show how easy it is to integrate many different AWS services with your backend SAP system. Okay, so how did we do it? How do we expose SAP business processes as APIs? Well, here's a reference architecture that customers can use to expose those REST APIs. SAP provides an API enablement solution called SAP Gateway. I'm sure a lot of you will be familiar with that. In fact, if you're using SAP Fiori to run your SAP applications, you already have an SAP Gateway system in the backend. While the SAP Gateway system can expose SAP APIs as OData services, to be able to scale and perform, you really need an API platform. And Amazon API Gateway is a great example of that. So Amazon API Gateway, it's an API platform as a service which will enable you to expose APIs securely at scale and both privately and publicly. When you augment it with Amazon Cognito and AWS Lambda serverless functions, as we just saw and as I described, you can create secure and highly performant API integrations without losing that user context across systems. So what's more, it also enables you to fan out and integrate SAP and non-SAP applications, or even SaaS applications, or your on-premise apps, of course. And this also enables multiple different interface types, as long as they can integrate with that API gateway. So you can see examples here of voice interfaces, such as Alexa, mobile or web apps, and IoT devices. And one such device is actually our AWS Deep Lens, which recently became available in the latest revision in many more markets. That AWS Deep Lens device is, of course, developed on Intel hardware. We work very closely with Intel for the underlying hardware, and that can be used for inference at the edge by building your models and then deploying them to run directly on the Deep Lens itself. And if you've joined us for any of the major SAP conferences like TechEd in previous years, you may well have seen me demonstrate exactly that use case using a Deep Lens at previous conferences. Okay, so let's move to another pillar, Internet of Things. So at AWS, we start our customer engagements for IoT with a simple question. If you knew the state of everything and you could reason on top of that data, what problems would you solve? So our mission is to make sure that you can know the state of everything, of all your devices, and that you can reason on top of all that data, so that you can then truly solve your business problems. So we all know by now that there's billions of devices in homes, assembly lines, oil wells, cars, you name it. With the proliferation of devices, though, you increasingly need solutions to connect them and collect, store, and analyze that device data. So how do we actually help? How do we fulfill that mission? Well, AWS IoT provides broad and deep functionality spanning the edge all the way to the cloud, so that you can build IoT solutions for virtually any use case across a wide range of those devices. As I said, like all our pillars, this is underpinned by AI and ML. Since AWS IoT integrates with AI services, you can make devices smarter even without internet connectivity. Built on the AWS cloud, used by millions of customers now in 190 countries, AWS IoT can easily scale as your device fleet grows and your business requirements evolve. It also offers the most comprehensive security features, so you can create preventative security policies and respond immediately to potential security issues. If you're not familiar with our IoT services, of course, in this webinar, I'm not going to go into a huge amount of depth on the services themselves. I do encourage you to visit our website to read more. There's a lot of information there that we have grouped by industry as well as by service, and it's an area of rapid growth both for customers and for us. You'll also see a number of major recent announcements specifically for our AWS IoT services that have significantly expanded that family. A good example of that is AWS IoT Events, a fully managed service to detect and respond to events at scale from sensors, connected products, and MQTT-based applications. So I did mention it's an area of rapid growth for customers as well. Here's a quick snapshot of some major customers working in the space. So again, I'm not going to go through all of these, of course, but just to call a couple out that are particularly relevant for our EMEA market. Enel, as you can see there, use AWS as their platform for IoT and energy management. So they're building AWS IoT Greengrass-enabled smart gateways for the home and industrial gateways for their power generation sites, where Greengrass will allow them to process and act on large volumes of data. British Gas are another very well-known logo in the UK market specifically, of course. And British Gas Hive Connected Home uses IoT to connect their smart home products, including cameras and water leak detectors. So we made a number of announcements at Sapphire this year. I'll be talking about a few of them throughout the webinar. One of the most interesting of these announcements is a new collaboration with SAP for IoT. AWS IoT already has a robust set of capabilities in the cloud and at the edge. We just saw that many customers are already seeing business benefits by marrying their IoT data with their business processes. So SAP Leonardo IoT also provides a set of capabilities that ties nicely with SAP business processes and supporting applications. With this collaboration, we're able to combine the power of SAP business processes with the global scalability and agility of AWS IoT. We're delivering two capabilities for customers through this collaboration. Cloud-to-cloud integration, where AWS IoT can be used for device management, device security, deployments, monitoring, rules engine, and error handling, while device telemetry information can be seamlessly integrated with SAP for downstream business processes. We're also delivering an ability to integrate SAP's edge services, essential business functions, within Greengrass. So this allows customers to use AWS IoT as a control plane for deploying SAP Edge solutions to Edge Gateway within Greengrass containers. And then finally, Greengrass and SAP Edge services can be integrated at the edge to drive SAP business processes with device data at the edge. So these are just a few examples of how AWS IoT is helping a lot of customers solve their business problems. For example, you can see predictive maintenance here. So Kempi are a great example here. They manufacture welding equipment, and they created an application that stores welding data to improve the quality of each weld and also cut software development costs by 50%. Pentair uses AWS IoT to improve beer filtration processes and boost performance by 10%. And then Teralytic are another good example, where they implement precision agriculture solutions and built-in machine learning models to detect changes in soil nutrients so farmers can increase crop yield. And again, the same theme is throughout here. As I mentioned, these pillars are all underpinned by AI and ML, and you can see that through our customer examples here as well. Okay, so let's jump to the next pillar, data and analytics. So this is a topic area where I'm seeing a lot of interest from our customers. The volume, the variety, the velocity of data continues to escalate. I'm sure all listeners will have heard this before. Data growth, and the proliferation of data are common themes and common pain points for our customers. Data sets are getting bigger and more diverse, coming from many different sources and applications, whether it be typical SAP ERP solutions, CRM, or others, and it ends up in silos. And the data volumes are also growing fast. So machine-generated data and logs are growing much faster than business data, thanks to network-connected smart devices, microservice architecture, and growing popularity of a DevOps culture. Data platforms also live for a long time, on average at least 15 years. So when you're thinking about building a data platform, you really need to think not just about your current data needs, but about your data volume and needs over that next 15 years. There are multiple teams who want to access data in a collaborative manner for use cases ranging from business reporting to ad hoc analytics to deep insights drawn through machine learning. They want the flexibility to self-onboard and share data, make data available for analytics in real time, be able to search and analyze data at massive scale, and do so in a manner that adheres to security and compliance requirements. And all of this is very much what I'm seeing with my customers throughout EMEA. It's a real hot topic, as I say, at the moment. And all of these themes and these end use cases are use cases that I'm seeing across many of the customers I work with. So where does that bring us? Well, hence we need data lakes. So data lakes allow you to break down those data silos and bring data into a single central repository. You can store a wide variety of data formats at any scale and at low cost. Data lakes provide you with a single source of truth and allow you access to the same data using a variety of analytics and machine learning tools. AWS delivers an integrated suite of services that provide everything needed to quickly and easily build and manage a data lake for analytics. AWS Power Data Lakes can handle the scale, agility, and flexibility required to combine different types of data and analytics approaches to gain deeper insights in ways that traditional data silos and data warehouses cannot. So this gives customers the widest array of analytics and machine learning services for easy access to all the relevant data without compromising on security or governance. There's more people running their data lakes and analytics on AWS than anywhere else. And this includes customers like Finra, Netflix, Amazon.com, NASDAQ, Atlassian, Cisco, Airbnb. The names go on. I'm not going to list them all, of course. And that's just to name a few. So again, it's not surprising this is such an area of interest for our SAP customers. But on that note, how can data analytics on AWS be useful for our SAP customers? Well, a lot of structured data, and in some cases unstructured data, gets generated in SAP applications. And customers are looking to liberate that data and bring them into cost-effective solutions like S3 to build data lakes. Once data is in S3, it's easy to build data lake capabilities using solutions like lake formation. One of the biggest questions SAP customers have is how to extract data from SAP applications. So for one, the data resides in both ERP solutions and SAP's own BW solutions, amongst others. Some customers have also built operational data stores using SAP HANA natively. Each of these applications have different frameworks and technologies to extract data from SAP. Our default recommendation for customers at this point is to use SAP's own data hub or other third-party solutions to pull data from SAP applications. And there's many of these third-party solutions that are that have certified adapters to pull data from multiple SAP sources. Many of them also support change data capture, which, depending on your use case for data extraction, can be a key feature. In some cases, like with SAP CDS views or iDocs that can be exchanged using open protocols like HTTP, customers can also write glue scripts, as you can see here, to pull the data from back-end applications. However, it's worth noting that these will, of course, be custom developments. Now, we actually do work with customers in this space as well, and our own professional services team are a team that I always give a shout out to here because I work very closely with them, with our customers, and they always do a great job. They are key, instrumental to working with customers who are willing to do some of that work and be a little bit innovative here and build some of these custom interfaces themselves. Now, that's the start of the architecture. But as you can see, once you get that data ingested to AWS, your options then open up. And that's the key point. Once you can consolidate your data in a data lake on S3 and AWS, you get all the benefits of that at an infrastructure level, but it also means that you now have possibilities open up for you on what to do with that data. A simple example of that is how you can analyze that data. So you can use Redshift or Redshift Spectrum to analyze that data either within Redshift itself or directly on S3. You can do ad hoc queries using Athena directly on S3. And you can visualize that data using Amazon Quick Starts, or again, third-party products. So third-party products that are very popular here, like Tableau, for example, run really well on AWS and are also a great solution if needs be. Again, this is all underpinned by machine learning. So it's all about getting insights into that data. Getting all of that data into one place is a great first step, but to generate insights into that data, you will be using machine learning to generate those insights. And again, machine learning is a topic all of its own that we won't have time to go into in depth here in the webinar today. But again, I encourage you to go look at our services in this space like SageMaker, which make it much easier to use machine learning to generate those insights. And then, of course, you have your data consumers, the applications. So we've already talked about how AWS services can help in the development and deployment of these applications and the integration between them and backend SAP systems, but they can also be consumers of this data on AWS natively. In the interest of time on this webinar, I can't show all the demos that I would like to, but if you're interested in a follow-up conversation to see this in more depth, do please reach out to us, or you can join us at one of SAP's major conferences like TechEd, for example, later this year, where we'll have many hands-on demos illustrating these use cases. Okay, and then the final pillar to talk about today is DevOps. So what is DevOps? Well, DevOps is a set of software development practices that combines software development, the development side of that, of course, and information technology operations, the ops side, to shorten the system development lifecycle while delivering features, fixes, and updates more frequently. So DevOps is, at this point, a well-established industry standard approach. But how can we apply it to SAP systems? Well, I will go through a few examples of that, but first let's look at the AWS services that enable this. More widely, developers have a great family of services on AWS to help make their lives easier. And these services can also be used for some SAP products, such as SAP Commerce, formerly known as Hybris Commerce. So these are services like Code Commit, Code Build, Code Deploy. Well, you can see them in the list there. And these are services that greatly simplify your version control management, your maintaining and creating a CI/CD pipeline, the development using web-based IDEs like Cloud9, for example, and even local development of serverless code using AWS SAM. We've also built out a family of services that help with the management of this more modern microservices type code and serverless development using services like AWS X-Ray, which allows you to trace your code and debug your code for serverless code using Lambda. But core NetWeaver-based SAP applications, of course, have their own source code version control and transport systems internal to the SAP system itself. And so this is why we'll focus more today on the runtime and operations services. So within our runtime services, there's a few services here that I would particularly like to focus on. EC2 autoscaling is one of those, and Lambda is another. So these are services that are key to enabling the elasticity, the ability to scale for rapid peaks and troughs or business growth, and to be able to integrate and use serverless functions with your backend SAP systems, all of which we've described earlier. So we're going to go through that in a bit more detail now. Another service worth calling out here that I won't go into in detail today is our Elastic Container Services. So we have two sets of services on for this, ECS and EKS. EKS is, of course, our Elastic Container Service for Kubernetes. Kubernetes has seen wide industry adoption, of course, and it's also being used by SAP for Data Hub. So I mentioned Data Hub briefly in our data and analytics pillar, but we actually also have under development a quick start for Data Hub, and that uses our EKS service. So it takes away a huge amount of the operation and management of Kubernetes clusters for you by using EKS. And with that quick start, of course, it also takes away the deployment and configuration that you need to actually get that up and running in the first place. I'll talk more about our quick starts in a minute as well in general. There's also the operations pillar here. So within that, we will pretty much use all of these services, and we certainly see our customers using these services very regularly. Today in particular, I'm going to touch on a few that I'll talk about in more detail in a minute. Those that I won't touch on in great detail, I'll call out here. So CloudWatch is our monitoring service, a key crucial service for monitoring the state of your infrastructure, alerting you to any issues. And what's also very interesting about CloudWatch is that because our services are all independent services with their own APIs, you can actually integrate and connect events between services. So you can use CloudWatch not just to trigger an alert in a traditional email or text message, for example, but you can also trigger follow-up events that you know should happen in the event of a particular alert being triggered. In other words, you can build self-healing mechanisms using CloudWatch and our wider array of services. CloudTrail is a very important service for auditing. So CloudTrail is used for monitoring what changes have been made in your environment. And this is a crucial service for being able to ensure that you have an auditable trail of the changes made. Systems Manager we'll use in our examples in just a minute, but it's worth briefly mentioning that Systems Manager itself is another crucial service for SAP customers running their SAP systems on AWS. Systems Manager allows a lot of different areas of functionality now. It has expanded greatly throughout the last few years. One of the key pieces of initial functionality that it supports is running remote commands on EC2 instances. Now, you can take that and wrap now automation documents around it to actually do a lot of sophisticated work across a fleet of EC2 instances that you can manage through tags. So you can arbitrarily select the fleets of EC2 instances that you want to run these operations on. You can use Systems Manager to also do patching and maintenance of your operating systems on those EC2 instances, set maintenance windows for when you apply that patching, amongst a host of other features. AWS Config is another one we won't talk about much in these upcoming demos, but it's one that's again crucial, and it's actually really the backbone of being able to translate some of these demos into real production use cases. Config is used to set guardrails and configuration rules around what changes you're allowed to make in your environment. And that's crucial for being able to set, as I say, guardrails around what your end users can do. Okay, but without further ado, let's jump in a bit more into some of the examples. So to do that, let's outline what we see are some of the typical operational challenges that our SAP customers have. So you can see listed on the slide here. Coordination between teams in particular is very difficult, so or not necessarily difficult, but certainly time consuming. So if you, as a basis team, need to request, for example, additional storage, in a traditional on-premises setup, you may need to request that storage by submitting a change request through some kind of help desk or ticketing system to the infrastructure storage team. And that takes time. And often, and I've seen this myself in my delivery consulting days, it can take quite a lot of time even for a simple request, because perhaps you filled out the form incorrectly, or they changed the forms since you last filled it out, or the help desk ticket just went down a black hole that nobody picked up. And as a result, this has a compounding effect. It's not just about that one change that got delayed. It's about the bigger picture here. By putting this inertia, this friction in place between your basis team and what they actually want to get done, this can dramatically slow down their work and also disincentivizes them from perhaps experimenting and being a bit innovative with what they can do. It also greatly increases the complexity of what you're managing. And because you need then more teams involved, it can also increase the downtime involved in maintaining your productive systems. All of this, of course, combined can greatly increase the costs as well. So again, I'm not focusing on infrastructure costs here so much. Of course, that is a big part of the picture, and you can certainly optimize greatly the infrastructure spend on AWS compared to the limits of what you can do on premises by cleverly scaling to meet demand only as and when you need it, for example. But that is often greatly overshadowed by the cost savings you can have at a people and process level. And of course, there's the lead time factor as well. So if you need additional capacity that's not already available in your data center, you now need to go through a whole procurement cycle. And that procurement cycle then needs to be followed up with delivery, with racking and installing and validating, reviewing. And all of that is before you even get to the software installation. So this can translate to a lead time of weeks or months for additional capacity or additional servers. So how does AWS help? Well, these runtime and operations services that I mentioned offer a chance to streamline those operations. So key to this is using infrastructure as code to build once and deploy anywhere. So I'm sure that many of you have heard of the infrastructure as code phrase. It's become almost a buzzword these days, but it is fundamental to how we see best practices for deploying on AWS. And on AWS, you do that through another service that was listed on our pillar that I didn't specifically mention. I'll do so now. That's AWS CloudFormation. And CloudFormation is a service that allows you to define your infrastructure as code in a plain text file, and then feed that text file or that CloudFormation template into the CloudFormation service. CloudFormation will then deploy what you've defined in that code. And then this allows you to deploy in a repeatable manner. And if you write that in a repeatable way, you can deploy across regions all around the world. So then this gives you the ability to deploy, as I say, globally. You can also now deploy in minutes versus the weeks or even months long cycle I just talked about on the previous slide. Because just take an example of our HANA Quick Start, you can deploy an up and running HANA environment, and that includes everything in the environment, not just the HANA database itself, in minutes instead of weeks or months. So it takes roughly 30 to 35 minutes to deploy that Quick Start, just as an example. You can also scale to meet the actual demand. So this has impact both at infrastructure level and again at a people and process level. So by being able to use EC2 autoscaling to meet the demand as and when you need it, you can spin up on-demand infrastructure and thereby save on costs because you're not using that infrastructure when you don't need it. Instead of sizing for peak, you're sizing for your actual baseline usage and then increasing dynamically only as and when you need it. But it also, much more importantly, often actually, means that you can make sure there is scale and capacity to meet the demand of your users. So in the example of NG that I gave earlier, this was crucial because it meant that large teams of functional consultants now had capacity and had environments available for them to run on. Now, if you think about what it would cost to run a team of functional consultants, just for one day, that can overshadow the infrastructure spend for an entire month, depending on the scale of your project. So that's just a brief example of how you can see this being transformational at a much more important and higher level than just an infrastructure alone. You can deploy complex topologies with ease. So because you'll be using infrastructure as code, this also means that you can effectively version control your infrastructure. You can version control your environments. So this greatly simplifies and makes much more rock solid the environment maintenance and change management of your environments. It also means that you now have a much more readily traceable audit trail of the changes made to your environments. Not just because we're a cloud trial service, but because you will be ideally driving your changes through these CloudFormation changes. This also means you can improve operational reliability because aside from the underlying infrastructure itself, this means that you are deploying updates and changes in a much more repeatable fashion. And so you can test these much more easily and readily and much more thoroughly, knowing that you're testing identical changes to what you'll be deploying in production. You can then combine with other services, as we'll see in just a minute. So, I mentioned our quick starts already. What are quick starts? Well, quick starts are, as it says on the slide, an easy way to deploy complex software. So what I mean by that is these are ready-built CloudFormation templates that will deploy third-party solutions on AWS in a single-button automated deployment. You can build once and consistently deploy, as we talked about, but also these are supported solutions. So these are designed to be production-ready deployments. This isn't just any CloudFormation template. These are sets of templates that have been built by the relevant SMEs in that area, and they've been tested to be production-ready. So as an example, we use our SAP Quick Starts for our own benchmarking and testing, for example, and we have customers who've used our SAP Quick Starts to deploy their production environments, and they run on those production environments to this day. So if you take a specific example there within the SAP HANA Quick Start, we actually deploy the EBS storage attached to the HANA systems in a way that ensures that you have the best balance of IOPS and throughput for the best cost by creating LVM logical volumes striped across 3 GP2 EBS volumes. And again, if you want to see more detail on that, go ahead and go to our Quick Start site and you can read more about that as well. So we're releasing quick starts pretty much actually more frequently than every week now, probably multiple times a week. We have, I think, upwards of 160 or 170 quick starts at this point. And within the SAP space alone, we now have 4 of these, with more in development, as I mentioned. So this is the Quick Start for HANA that I mentioned. You can deploy this as either a single scale-up HANA system or as a scale-out multi-node HANA system. And you can also deploy this as a single AZ or multi-AZ deployment. So I won't go into any great detail on our availability zones, but suffice to say that within each AWS region, of which we have 21 worldwide right now, with more on the way, of course, each region is comprised of typically 3 or more availability zones. And each availability zone is itself a cluster of 1 or more physical data centers. And each availability zone is also separated from each other by every mechanism that we know how to ensure the resiliency of each availability zone from any failure that would affect another. So they're separated by floodplain, they're separated by power suppliers, network vendors, just as an example. So deploying across multiple availability zones is one of our best practices for ensuring fault-tolerant architectures. And that's why with our HANA Quick Start, we modified it to actually allow you to also deploy across multiple availability zones. So with deployment of the Quick Start, you can now have an up and running high availability HANA setup across multiple availability zones, as well as a single AZ deployment. So worth also stopping to mention here the S/4HANA Quick Start. So I mentioned that I had the pleasure of announcing that at Sapphire earlier this year, and so that's out just a couple of months now, but it is an end-to-end automated deployment of an S/4HANA landscape in just 2 hours. So it takes between 2 and 3 hours, but that's because you can also deploy the S/4HANA Quick Start in either a single AZ or a multi-AZ high availability HANA installation, as you can see there. It supports installations of S/4HANA 1809 running on HANA 2.0 SPS 03. And you can see here exactly what that deploys. So just to give you an idea of what you can automate with CloudFormation. With a single AZ deployment, you are deploying a public and a private subnet, a HANA database server on EC2, and a central services server on EC2, a primary application server, and any number of additional application servers that you want as well. It will also deploy, optionally, an RDP host and a Bastion host for you in a public subnet to allow Linux access for SSH or Windows access over RDP. And it will also deploy a NAT gateway in that public subnet to allow outbound internet connectivity from your private subnet. It also sets up your Route 53 domain name if you go for a high availability setup. It'll also set up EFS optionally for deployment of your global file systems on EFS, which is essentially an NFS managed file system from AWS. And it can also set up, as you can see, an autoscaling group for ensuring availability of your Bastion host. As well as all of that, it also configures your roles and authorizations. So your IAM roles and profiles are created and deployed as part of this Quick Start as well. So it will truly deploy an entire environment, either in an existing VPC or in a new VPC, if you so choose, for you, all in this one end-to-end deployment. And you'll be left with a running S/4HANA system that you can actually log into. As I say, you can also deploy this in a high availability fashion by deploying a secondary HANA database server and a standby central services in a second private subnet in a second availability zone. And again, if you do that, you'll also be deploying a public subnet in that second availability zone also to ensure that you can fail over all parts of your landscape to that second availability zone, not just the traditional single points of failure. And that's a key point because, of course, for high availability and ensuring availability, you need to look at the weakest links in the chain. A couple of other examples that I'll briefly go through in our last few minutes are on also how to leverage our wider AWS services to streamline your operations. Here's an example, again, of a chatbot. So I mentioned I'd have another example of this. And this is a chatbot built in Lex that we've integrated with Slack because it's a common productivity team collaboration tool for users that allows end users to trigger common SAP operations. And this makes it easy for even non-technical people to trigger complex operations. So what if you could use AWS services to provide a new interface mechanism for those end users? You would be able to potentially, again, remove even more of that inertia. So we talked about some of the inertia the basis team can face, but what about those functional users or those test or power users who want to be able to have an environment that they can make changes on, or developers who want to make changes and then run backups before continuing? Rather than having to trigger a service request to a basis team, what if they could actually just go and chat to the SAP system to ask it to make those changes? So this is actually a demo that we've run at a number of conferences already this year and last year, at TechEd, at Innovation X in London, and at Sapphire. And what it will allow you to do is a number of different operations. One of the key operations it will allow you to do is autoscaling your SAP servers. So I mentioned this already, but autoscaling your SAP application servers dynamically allows you to address performance requirements during peaks. And now you can do this dynamically, as I say, or you could do it on a schedule basis if you have predictable peaks and troughs in your SAP workloads. But the key is that this allows you to be sure you can meet those capacity requirements while minimizing your infrastructure spend. And here's a quick snapshot of exactly what that looks like. So again, if you want to see this in action, do please reach out to us or come visit us at our booth at any one of the major SAP conferences, as I say. But here's a mobile app version of Slack that we have asked to add application servers. Now, in this example, we've just added a single application server, but you can actually add multiple application servers at the same time if you want. Now, this is a demo. And so this isn't production ready. I want to be clear on that. This is a proof of concept. And why it's important to call that out is because actually you could take this and you could productionize it very quickly by putting guardrails around it. What's one of the key concerns you'd have with something like this? Well, it's probably going to be that your end users will spin up additional environments or additional capacity without really being frugal about how they're doing it, or without looking at what's already available, for example. And so probably you're going to want to put in place guardrails to ensure that they they stay within those capacity limits. Maybe you want to check if there's existing capacity before automatically approving their request, for example. And again, this is where other AWS services like AWS Config come into the picture. So it doesn't just allow autoscaling of SAP servers, it also allows automating your SAP backups. So as I mentioned in the example of a developer, you can also use this to start and stop your SAP environments. And it will start and stop them not just with a system start-stop, but it will actually intelligently go and start up the database server first and then the application servers on top of that to ensure that the system is brought up correctly, and vice versa for when you're shutting those systems down. So again, the key aspect of this is enabling your other teams. It's about seeing that the real change here is at that people and process level, not just at the underlying infrastructure level. And the final example of that is with our serverless refresh. So this is a solution that a colleague of mine built with a customer of ours, Zalora. And what this allows you to do is a common everyday SAP operation. Every SAP customer will usually multiple times a year refresh their non-production SAP systems from production. And this is to ensure a number of things: that they have consistency between environments, that they have up-to-date production data on which to test, that they're doing true like-for-like testing when they move from non-prod to prod, for example. But whatever your reasons, it is something that pretty much every SAP customer will be doing. And in the traditional on-premise world, this can often be quite a painstaking process. That could mean you lose your non-production environment out of your route to production, your BAU route, if you will, for traditionally up to a week or more. Now, what Zalora did in working with one of my colleagues is they built a solution using step functions and Lambda that will actually do this refresh by creating an AMI of an existing system and an existing QA system, for example, and then taking a backup of production, restoring it into that copy, running the post-copy changes, and then making that available as your new QA environment, effectively throwing away your old QA environment. Now, what's key about that is that it did two things. It reduced the refresh time from 5 days to under 2 days. So again, as I say, from a traditional week-long refresh to under 2 days. But it also means that you don't need to change out your running QA environment for the new QA environment until it's ready. And so it also means that you're actually reducing the time that you're taking your QA environment out of your BAU route to production for anything from minutes to hours, depending on how rapidly you can switch over. And so this can make a really big difference to the release windows that you have into your production environments, and therefore accelerate your rate of change. Of course, there's a bunch of other benefits as well, as you can see here. A reduction in human error, it makes the process more repeatable. You get increased user productivity, and because it's based on serverless services, you've also got very little maintenance of the actual solution itself. And because serverless services are used only as and when you need them, they have a pure consumption model for billing. And so this is also an incredibly cost-effective mechanism. So we have a demo here, but with only 5 minutes left in the webinar, I'm going to quickly skip through the demo just to show you the highlights to ensure we have time for some questions. Apologies. So, silly of me not to mute it. So, in this demo, you can see our EC2 console here, and this is the list of AMIs created. So, in this demo recording, you can see that we've already got the AMIs created. Now, AMIs are Amazon Machine Images, which essentially are VM images of the entire virtual machine. And we're going to use this AMI to create a clone or a copy of the existing QA environment. So I'm just going to skip through this. Again, normally I would run through this, but I just want to make sure we've got time for some questions. I see we've got questions built up. So if I just skim through the demo, you will see that we've also got our parameter store. This is another feature of Systems Manager, as well as some of the other features I mentioned. You can see on the menu bar on the left there just some of the functionality that Systems Manager now supports. So in this solution, we use parameter store to hold all the necessary information about the refresh. So what are the post-copy changes you're going to make? What are the hostname changes, the instance type, the system number? Where is the backup location for the production backup that you're going to use to refresh, etc. So we'll skip past all of those parameters, and we'll jump to our step functions console, because this is where you'll see the state machine. So step functions is an AWS service that allows you to create state machines to orchestrate the flow of a process. In this case, it's the flow of the system refresh process. And so if I skip on and we go into that system refresh process that you can see is active in this recorded demo, you'll see that the state machine is created by defining a JSON file. And that JSON file is interpreted by step functions to define a process flow, which you can see on the right-hand side. And when you actually run that step functions state machine, it will step through every part of that process flow and execute the associated functions with each step. And so that's where we're calling our Lambda functions, as I mentioned. So when we start, you can see that we initialize a DynamoDB table, and this is simply to record the state of the step functions. So we know we can restart at the appropriate point if there was a failure on a specific step. So you can see the names of the functions that are being called as we step through the step function state machine. You create the duplicate instance, then you'll copy the backup from S3. This is from the production backup, and then you'll stop your HANA system. So you'll run through a number of steps to do your exports. You will take your copy of your transports and apologies, I don't know why that happened, and you will use those transports to reload them into the resulting cloned environment. And that is so that you can continue the changes from where you left off in your QA environment for in-flight changes that didn't already make it to production. Okay, so that's a very quick view of the serverless refresh. For more information on that, we actually have a video on YouTube where we talk through with Zalora exactly how that works. And here are some of the other resources that you can also use. So apologies for running slightly over. We have 1 minute left. I'm going to jump into the questions. For those of you who have to jump off, I will spend the extra time going over the hour to answer these questions. So if you want to come back and view this on demand later to see the answers to those or hear the answers to those questions, feel free to do so. So thank you very much, everyone. I hope this has been interesting. Let's jump into the Q&A. So, Francesca, let me bring up the questions. Thank you for letting me know. Let's have a look. Okay, so we have a few questions here, as Francesca has told me. So, did I read correctly that you can scale out on ERP? So yes, for S/4HANA specifically, you can. So this is something SAP have been working on for quite a while now. You can do scale out of up to 4 nodes, and we support that. That is now certified on our high memory instance, 12 terabyte instances, which means that you can scale out up to across 4 12 terabyte nodes, which means you can now run up to 48 terabytes of in-memory S/4HANA systems on AWS. Okay, what else do we have here? When will the new larger instance types come out? So I'm sure this is referring to the 18 and 24 terabyte high memory instances. So those will be coming out in the fall of this year, so later this year in 2019. And those will be further iterations on the Nitro platform I mentioned earlier. If you want more details on the Nitro platform, by the way, again, Adam's webinar from last week, which is available on demand, is a great listen for that because Adam goes into quite a bit of detail on the Nitro platform, the journey we've taken there, and how it's enabled us to have such high memory instances available in the cloud within your VPC as native EC2 instances. Okay, and a question that I think I've probably already answered in the last few slides of the webinar there. Can I see the demos myself? You can check out the repositories for samples. You can see it there listed in our resources. And we also do hands-on demos at major conferences also. So like I said, at TechEd, for example, Innovation X earlier this year. And you can also reach out to your AWS account team or just reach out to us directly as well if you want to talk about this in any more depth. So I mentioned, or I can see a question here, how do I find out more about SCP? So I mentioned SCP, of course, throughout, especially for the early integration parts with our announcement about our integration between IoT and Leonardo at Sapphire. So if you want to find out in more depth, I would recommend you either reach out to your SAP account exec or go to their website where you can find more detail. Okay. So I'm just seeing a couple of more questions. Do you have a template for SAP Hybris build pipeline? So we do not have a template for that, I'm afraid. However, we do have expertise within our professional services team that I've mentioned already, and they'd be more than happy to work with you on that if you want to discuss that with them as a possible engagement. So again, do please reach out if you want to go into that in more depth. For API, IoT, and analytics, we can still leverage AWS capabilities even if SAP is not migrated to AWS, for example, on premises, correct? Yes, that is correct. In fact, we have customers doing that right now live in production, some very large customers, and it works just fine for them. The The key thing to bear in mind is your specific use case, any latency concerns you might have, any timeout concerns you might have. For example, on a long-running request that could take a long time to return from the back end, you want to be careful of timeouts. And there are some other specific gotchas as well that if you're looking to develop that in more depth, do please again reach out to us and we can work with you on that. But it's certainly possible to do, yes. And the last, is there a detailed step-by-step guide for the SAP system refresh? Yes, so there's a, it depends on exactly what level of detail you're talking about, I guess, but there is a YouTube, this is my architecture video where where the writer of that solution, Harpreet Singh, talks through exactly how it was built with the customer he built it with, Zalora. And so you can get a lot more detail there. And if that's not enough detail, then again, do please reach out and we can help you with that. And just like Francesca said, the use cases and case stories, you can see those in more detail on our website as well. So thank you for that, Francesca. So a great extra resource to throw up there. You'll also see the other resources we mentioned here. So one thing I'm not sure I mentioned about our Quick Starts is that they are also open source. Just like our AWS documentation itself, our Quick Starts are actually open source. So you can take those, and if they don't fit your needs exactly, you can go ahead and clone those GitHub repos and feel free to customize them to your needs. Okay, right, so I think that's the last of the questions. Thank you very much for the interest. I hope this was useful. And given that we've now run 5 minutes over time, we'll better wrap this up. Again, do feel free to reach out to us if you have any further questions or you want to go deeper on any of those topics. Thanks again.